Chapter 6 Work, Energy, and Power. Chapter 6.1 Work and Energy Transfer. 1. Work, a way of energy transfer. The energy transferred due to temperature difference is called heat. On the other hand, energy can also be transferred by applying a force. Such energy transferred is called mechanical work, or work done, or simply work. For example, when we pull a cat or when we lift something up, we do mechanical work, and we do work. A. Parallel cases. Work is done when a force is applied over a displacement. The work done is given by F times S, where F and S are parallel. The unit of work is Joule, J for short. So, a 1 Newton force applied for 1 meter will produce a work of 1 Joule. In figure 6.1c, if there is no friction, the applied force will accelerate the mass, and the mass gains kinetic energy, and therefore Fs equals kinetic energy gain. On the other hand, if there is friction, the work will partly or completely becomes work done against friction, and so Fs equals the sum of work done against friction and Ke gain. B. Work and energy change. Without friction, the applied force is the net force that will accelerate the mass. The mass gains speed, and therefore it gains kinetic energy. We say that the mechanical work becomes kinetic energy of the mass. On the other hand, if the applied force and the displacement are in opposite direction, then the applied force slows down the mass, and the kinetic energy of the mass is reduced due to the applied force. We say that work is done by the mass against friction. In such case, the applied force is a retarding force. We may also say that the applied force does negative work on the mass. C. Non-parallel cases. If the applied force makes an angle with the displacement, the work by the force is due to the component parallel to the displacement only, and therefore in this case F cosine theta. The work is hence F cosine theta S, or Fs cosine theta. In particular, when theta is 0, cosine theta equals 1, the applied force and the displacement are in the same direction. While if theta equals 180 degrees, the applied force and displacement are opposite in direction. It is also interesting to note that the following cases produce no work. First, when a spacecraft is in outer space, where there is nothing else nearby, it will travel at constant velocity, and there's no work on the spacecraft as there's no force added on it. In the second case, there is also no work on the barbell when the weightlifter holds it still, as there is no displacement. Lastly, there is also no work done on the mass when you hold it and travel at a constant velocity. Spend a minute or two on the explanation given on your textbook. In example 1, 2 people push with a 8 Newton force at different angles. They do different work according to the formula W equals Fs cosine theta. 2. Total work done. When there are more than one force acting on a mass, the total work done equals the work done by the net force. In example 2, there are 5 forces acting on the mass. The net force is 10 minus 10 cosine 60 degrees minus 1, that equals 4 Newton horizontally to the left. The work by the net force is 4 newtons times the displacement s. Now please try the checkpoint question below.